All right, so part 2 of solving literal equations.
That's pretty literal. It's pretty literal.
Okay. My advice, use a highlighter. When you're dealing with only a bunch of letters and occasional number, the thing you're solving for, like this, can get lost. So I would utilize a highlighter to keep track of what you're solving for, the variable that you're solving for. Now, let's also remember all the crazy here. When we get down to this level here, and we have AB plus AC, and we're solving for A, we pull the A out and multiply it with the B plus C. Do you remember this yesterday? When we have something that looks like that, we pull the A out. And then we can divide both sides by the B plus C. Remember this? Remember also up here, when we're multiplying by this denominator, we're multiplying it like the distributive property with everything on top. That B is being multiplied with everything on top. You guys up until now would just be multiplying it with one thing up there, basically. This is new for y'all, okay? So now we've got a lot of stuff going on up there. So when you're trying to get rid of a denominator and you're multiplying it on both sides, you're multiplying it with everything on top. Just like right here. Got rid of the C, you're multiplying it on both sides, but with everything on both sides, kind of like distributive property. Hopefully you guys took really good notes yesterday. Okay, we started doing examples. The last one we did was number 17.
That means that we're doing it.
Shh. I highlighted what we're solving for. This one, remember, was kind of crazy. And I mean, if you're stuck on some of these ugly ones and you need me to just kind of give you a nudge, I can kind of help you out. It's like solving a puzzle. Like Taylor yesterday was like, well, we could try going this direction. I remember actually last year, Chap and I, on several problems, trying multiple ways of solving it. Sometimes it would work, sometimes it wouldn't. Okay, I will also reiterate, you may not think this is important. Last night, Allie's, I think it was her chemistry class, she had this stuff to do. And it was either her calculus class or her chemistry class. I can't remember. And it was weird stuff, just like this. And she had to solve for, like, it would be area equals pi r squared. And she had to solve for the r. So she had, and it was a lab, so it must be her chemistry. But anyway, she had several where it was a formula and you had to solve for one little letter in there. And I started laughing. She came in, she goes, man, I forgot how to do some of the stuff. I said, interestingly enough, I'm currently teaching Algebra 1, the same stuff. So you will be needing to do this again. You could be like her and not remember though. Okay. 19. S equals, y'all ready? 2 pi r capital H, all being multiplied, plus 2 times pi r squared. And you're solving for the capital H. This is just kind of like what she was doing last night, interestingly enough. I should make her watch these videos. All right. We're solving for H. So here we have a bunch of stuff. I'm going to go ahead and highlight H so we can focus on what we need to have all by itself eventually. Can I have a volunteer? Gabby. She is brave, y'all. Okay, so Gabby, we're solving for this. What do you think is the first thing I should move?
Subtract to both sides by 2 times pi r squared.
Yes. Okay, so look here, guys. Look up here. If this H is in this term together. So she said, let's go ahead and get rid of this term right here. And she's correct. Let's just get rid of it. And that's kind of nice when it's all together like that. And since we're getting rid of the whole term and it's adding, she said we're going to subtract the entire term on both sides. That cancels. So I have S minus 2 pi r squared equals 2 pi r capital H. Okay. Now, Gabby, what do you think? We got to have H all by itself.
We're going to divide both sides by 2 times pi r.
Okay, so look here, guys. Cecilia, your eyes should be on the board unless you're copying this down. So we want to have H all by itself. Everything in this term is being multiplied. So if we want to get rid of part of it, like that, we're going to divide everything by 2 pi r. So then that cancels, and we're left with S minus 2 pi r squared divided by 2 pi r equals H. And we are going to stop there, because that's where I want my students to get to. I will tell you a little secret. Allie's lab, you enter the answer and it immediately tells you if it's correct or not. Okay? Oh, it's coding, so it must have been engineering. I don't remember which class. Okay. Well, sorry, guys. Okay. So one of the things we did got to like this point, and I said, okay, here's the thing. Does your lab, okay, that's technology. It's not her teacher. She submits it online. Are they expecting it to be simplified or not? And she goes, well, you're allowed like 3 tries to get it right. Okay. So the very first one she put in there, which is perfect since we're in the middle of this, she put it in not simplified, and it worked. They did not count it wrong. This is college. They did not count it wrong. It was a lab, and it was for coding, so it must have been her engineering class, and the code worked. It performed something. So what that tells me is even if you're going into engineering, computer programming, which is what some of this is dealing with, whatever, it read it without being simplified. So my view as your teacher for this assignment, especially since you're in 8th grade, get it to this point and you're going to be okay. All right? Make sense? Okay, yes, sir.
Are we not going to get points to get us not simplifying anymore?
If it's a fraction like this,
No, not like the like for.
no.
Yeah.
No. This will be okay for this stuff, 100%. And I was kind of glad that she had that homework last night, because that's always been my question with this, is to what degree would just getting here be okay? And according to Texas A&M, this is okay.
Oh, that's where she decided to go? That's
Yeah.
okay.
And she's in engineering, so she's doing coding, and she put it in, and it worked. Okay. I'm not saying it always will be, but the chances of all of y'all going into computer programming and this being an issue. So if you can get to here, you're doing good. Okay. AX plus B plus A times X plus B equals B, and we're going to solve for X. Whoops. By the way, I didn't ask, does anyone have questions from above? Okay. So 21, we're solving for X. I am fighting with pre-algebra. Literally, still half the class will not write out the equations. They will not show step-by-step for intruder alert. They're trying to do it all in their head. And I even showed them y'all's test. And I said, y'all need to get in the habit of doing step-by-step and showing it all, because it will come back to haunt you later. They just don't want to do it. And it's scaring me for them next year because, you know, look at this.
Was there anyone here? Like, we weren't really like that, though.
No.
Right? We would,
I think Taylor's my only stubborn person back there that has to do it his way and fought me on it. But even he's doing better. The others are just like, no, I'm going to win. I'm like, no, you're not. Okay. Who would like to do this one? Cecilia. Ooh, brave Cecilia.
Mr. Rogers.
Hey, shh. I said Cecilia, not Taylor. All right, so Cecilia, what do you think is the first thing we should do?
Multiply A with X and B.
Very good, right here, distributive property. A times X and B, because everything in the parentheses. So I'm going to rewrite my problem. And A times X is what, Cecilia?
AX.
And A times B is?
AB.
Rock and roll. Good job. Okay. Now, I'm going to let you look at it and tell me what you think we should do.
Subtract AB.
Okay. We can. Well, first, can I ask you a question? Can we do any more simplifying right here?
AX and AX.
Yes. We have some like terms. Now, Cecilia, you weren't wrong, but I was going to make this even easier on you. Notice we had, so what y'all need to do is kind of make sure you simplify first. So AX plus AX is what, Cecilia? We're not multiplying, we're just adding. AX plus AX. If there's no number, we pretend there's a. So AX plus AX would be 2AX. Very good. Does everyone see that? Now, Cecilia, what do I do?
Minus AB.
Okay, so she's going to go ahead and move this term. So she's going to subtract AB on both sides. And I get 2AX plus B equals B minus AB. Very good. Now what?
Subtract B.
Subtract B on both sides. Now look here. Can it be combined with this B here, Cecilia? So B minus B is?
0.
That's right. And we can put 0 minus AB, or we can just write 2AX minus negative AB. Do y'all see that? Sit back and look at this. to make sure you then stop me at any time if you have a question like, why did y'all do that? Da da da. You know, we're all family here. Don't be embarrassed. We talk. Okay. Now, Cecilia, tell me what we do when you have it written and you figured it out.
Divide the 2a.
She's correct. This term, we want to get x all by itself, so we want to get rid of the 2 and the a. Since they're all multiplying, she is correct. We're dividing everything by 2a so we can separate it. And we get x equals negative ab over 2a. And yes, you can keep it there. If you wanted to simplify it, it would be x equals negative b over 2 because we can eliminate the a's. But I'm saying it's okay to keep it there. I will not take points off. I am happy if my students can isolate the variable. Now, if there's numbers, yeah, go ahead and you know, yeah. But letters, let's just be happy we're there. Any questions? All right, one more and then I'm setting you free. Home free. 23. I have nx over b minus n equals x, and we're going to solve for n. Oh, we have a couple of n's in there. All right, do I have a volunteer that hasn't had a turn? Taylor.
Okay, divide both sides by b.
Okay. Now, I want y'all to look at this.
Wait,
Wait, no, you're correct. But I need y'all to look at this. We have this right here. Now, he could add in over here and then later bring in back over here. Okay, he could do that. Or he can get rid of the b and multiply it by everything. But if you're gonna multiply the b before you move this, you have to multiply it by this n, and the x. See what I'm saying? You have to multiply that b by everything. So it truly is your choice. So do you want to go ahead and do that? Get rid of the b?
Yep.
Okay, he wants to get rid of this b. So again, look at what I'm doing. We're going to multiply that term by b. And I'm going to also multiply this n by b because you got to do it by everything. So I have nx minus bn equals bx. Before he moves on, does anyone have any questions as to why we multiplied that n by the b? Because we're getting rid of that, and you know how we always make sure this is over here and then we multiply both sides. Well, if you want, you can leave it, but you have to multiply that denominator by everything. Do you understand? Make sure your notes are nice and neat so you can refer back to these. Okay, so Taylor, what are we going to do now?
Do we do backwards? Yeah. So n parentheses x minus b.
Okay, so see the two terms? They both have n in common, so he's pulling the n out, and we're left with x minus b equals bx. Very good. Backwards distributive. Make sure your notes are nice and neat. Okay, now what do I do?
Do you subtract the other setbacks? Or do you divide those?
What are we trying to get rid of?
X and B?
We're trying to get rid of the whole thing, right?
Oh, yeah, okay, so bx divided by x minus b.
Okay, so since n is multiplying with this whole thing, we're going to divide both sides by that whole thing. And those cross out, and I'm left with n equals bx divided by x minus b. And we're leaving it like that. Are there any questions? I will tell you, Allie had, like I said, she had just this right here, and we had to solve for r. Took us a while because there was an exponent. And then she had another one that I was like, oh my gosh. We had to think back at all the rules that go along with everything. Like if you have a square root and the denominator can't have that. Y'all probably, we did it last year, but anyway, there's a lot to remember with this. So you have to kind of sit back and think about it. It took us a while. Yes, Cecilia?
So you just moved the other end with the other end?
This right here? Okay, so we have two terms with n. So he took the n out and did that backwards distributive property, and we're left with x minus b. So see, if we were to check it, n times x is nx, n times negative b is, or nb or bn. Okay, so if the two terms that you're left with have the letter you're looking for, take that letter out, and then what you're left with is x minus b. Does that help? Yes?
Can you do it with more than two? Like more than two of them? Like say like if there's another one like x or bx, like if that was in.
Okay, so I hear what you're saying. So let's say it was nx minus bn plus cn. So there's the letter I'm looking for. So yes, I can pull that n out, and I'm left with x minus b plus c.
Should we write this?
Only if you want. Do you see what I'm saying? So yes, if you had 3 here, you pull out what they have in common, and then x minus b. Because look, we do distributive. N times x is nx. N times negative b is negative bn. N times c is cn or nc.
If you had like another n, like just without another letter, would you keep it or would you put it? Would that be like would you multiply it? If it was like nx minus bn plus cn. Plus
I gotta look at it. Let's see. He's saying if I had nx minus bn plus n.
Yeah.
You could, I think, now correct me if I'm wrong, Taylor, y'all need to be looking. I think if we took the n out, wouldn't it be this? So if I were to pull out the n, because, let's check it, n times x is nx, n times negative b is negative bn, and n times 1 is n. So that would work. Good question. Any other questions? All right, so you are doing page, yeah, go ahead.
What if that negative bn, what if that was negative ba or something?
Well, then we'd have the ba would be moved over.
But then, okay, and then you could do the nx plus.
Yeah. Okay. Okay, so that's like 14 problems. I think. Maybe one more. Honors. 6 through 24 even. Ooh, I'm gonna challenge all day. I know it's Friday, but I'm going to blow your minds. 30, 32, 44, and 46. Alright, that is due Monday. I think I'm probably going. Your quiz is going to be probably like Wednesday, but I got to check on that. So it's going to be somewhere around there. It's not going to be like Monday or Tuesday. I'm not doing that. I think I originally had it for Tuesday, and I'm moving that. Okay, get started.